This video demonstrates how to create your own object class. We'll then model with this class and demonstrate inheritance by changing a property in the class itself. This property will then automatically be changed in all of its instances. To start creating the model, we expand the folder Material Flow in the class library. Click the object station with the right mouse and select Duplicate. This creates an object called Station 1 in the class library. Click the Station 1 with the right mouse button and select Rename. Enter My Station and press Enter. Move it up in the structure. Next, we add our class to the toolbar Material Flow in the toolbox by dragging the object to the toolbar and dropping it there. Now we are ready to model with our class. On the Ribbon tab, View, select Planning View. Now we see the scene and the grid from the top. This makes it easier for us to place the objects in the right position. We'll build a production line by inserting a source, 2 instances of My Station, and a drain. We then connect them. We also insert a chart to show the results of the simulation run. Drag the objects My Station and My Station 1 to the chart and drop them there. As we want to check the statistic values of the resources later on, we select Resource Statistics in the dialog that opens. Switch off Planning View. Now we're ready to run the simulation. Click the right mouse button and select Reset and Start. The chart shows that the stations are working all the time. This is not very realistic though. This is because our station has an availability of 100%, meaning that it never fails. To change this, let's decrease the availability in the class. Double-click My Station on the toolbar to open the class object. Click the tab Failures and click the button New to add a new failure profile. Type in an availability of 80%, then click OK. When we open the instances of My Station, we see that they now also have an availability of 80%. This means that they inherited that value from the class. Finally, we run the simulation again. When we check the chart, we'll notice that the stations now also failed, that they were blocked or were waiting for parts. Double-click the Drain object to open its dialog. On tab Type Statistics, we see the throughput per hour of about 40 parts. Next, we are going to increase the throughput of our line by reducing the blocking time and the waiting time. To do so, we insert a buffer between My Station and My Station 1. Select the buffer on the toolbar Material Flow. Hold down the left mouse button, drag the buffer over the connection between My Station and My Station 1 and drop it there. This will split the connection and insert the buffer between these 2 stations. Double-click the buffer to open its dialog. Enter a capacity of 4 parts. Click OK to close the dialog of the buffer. We then insert another chart and drag the buffer onto it. Plant Simulation will ask which type of chart it is to show. Select Occupancy to see the number of moving objects located in the buffer over time. We will notice that Plant Simulation changed the icon of the chart. Next, we run the simulation again and view the values. Each of the individual columns in the histogram represents the time portion of the simulation time during which the respective number of parts was located in the buffer. We open the dialog of the drain again and check the throughput per hour on the tab Type Statistics. We see that adding the buffer increases the throughput to a value of about 46 parts per hour. To check if the throughput increases, if we increase the size of the buffer, we change its capacity from 4 to 10 parts. Reset the model, double-click the buffer, and enter the new capacity of 10 parts. Then run the simulation and check the values again. Checking the chart, we see that the portion of the waiting time and the blocking time of both stations decreased. Checking the type statistics of the drain, we see that this also increased the throughput per hour.